Hi guys, today we're going to talk about stoichiometry. Now, stoichiometry is not just a fun word to say, it is also a way in chemistry that we can go and figure out ratios of chemicals either on the reactant side or our products. Very beneficial. I'm going to show you how to use it now. Okay, we balanced equations in the last chapter. So we see that now is I have two parts of this is right here, C3H7OH, which is isopropyl alcohol, to 9 parts oxygen gas. All right, now Zach, are you in close enough? Can they see that well? Okay. That's going to produce 8 parts of water and 6 parts carbon dioxide. Now, typically, if we're not given certain amounts or specific amounts, we will say, just use the term mole. Okay, so for every 2 moles of isopropyl alcohol, I need 9 moles of oxygen to react with it, and it will in turn produce 8 moles of water and 6 moles of carbon dioxide. Very, very beneficial. Okay, because once we have it in moles, we know what a mole can do. If we want to count particles, we can count particles. If we want to figure out volume, we can do volume. If we want to do mass, we can do mass. Okay, that's why we took the time to do moles earlier. Alright, so let's say that I have a reaction. I work in a factory. I want to be as precise as possible. I don't like to waste money. Nobody likes to waste money. So we're going to figure out exactly how much oxygen gas we need to purchase to mix with our isopropyl alcohol, because we are going to produce water, the cleanest, best water in all the lands. Okay, so if I know that I need to produce, let's say that I need to produce 3,000 kilograms of water. That is my goal. That is what I need to produce. How much isopropyl alcohol am I going to need to have to start off to make that? Okay, so in order to produce this 3,000 kilograms, that's what I start my equation with. We're going to figure out what's going on with that. How much isopropyl alcohol will we need? So 3,000 kilograms. Most of these are going to start with emission analysis equations just like we did with regular mole things. So it's nothing too far off of what we've been doing. Okay. Now, we need to make sure we get into kilograms though, or into grams. Kilograms we're going to use in physics, grams is going to be a physics or a chemistry thing. So 1 kilogram is going to be equal to 1,000 grams. And now this is kilograms of H2O. We weren't really sticklers before as far as writing this, but it's going to come more and more into play because we're going to be converting not just between units, we're going to be converting between substances. So I want to write water in here as well so I don't get confused. Alright, now I don't want grams of water, I want grams of C3H7OH. Okay, so that's where we need to get to. Okay, so I'm in grams. I can't get anywhere in grams. In grams, though, I can go to moles. Okay, so grams of water into moles of H2O. Alright, my magic number for mole is still 1 here. We're going to use another number for moles here in a second, but we're not quite there yet. Grams for water, we're going to do that the same way we've always done it, where H is 1, I have 2 of them, so 2 plus 16, we're going to call it 18 grams. Remember, you are going to be more precise than me. This is for demonstration purposes only. Alright. I don't want moles of water though. Again, I want to get to isopropyl alcohol. So my moles of water is up here. Now let's put moles of H2O on the bottom. And I have what's called a mole ratio. Okay, this step is called a mole ratio step. For every 2 moles of C3H7OH, I need 9 moles of O2 to produce 8 moles. This is what we talked about earlier, to produce 6 moles of CO2. So, I should be able to predict by my numbers of moles of H2O how many moles of isopropyl alcohol I need. So I'm going to put mole of C3H7OH in there. Okay, so now I can plug numbers in. Before we used 1, now we use the mole ratio numbers. And in this case, H2O is 8, and isopropyl alcohol is 2. Alright, moving on from there. Now I've gone from moles of H2O into moles of isopropyl. So, moles of isopropyl, I should be able to go to grams of isopropyl. Okay, and when I do that, now I go back to using the 1 as my mole number. And my gram in this case is going to be the gram molecular mass of isopropyl, which is going to be 12 times 3, 36, plus 8 times 1, which is going to be 44, plus the 16, so that is 60 grams. Alright, I'm going to come back after I get my handy-dandy calculator, and we'll go and figure this out. Alright, Zach was kind enough to come in here and get a nice, tight shot of this. I know some of you are going to be mad at me because you couldn't see it earlier and you tried to figure it out. But here's the actual up-close footage of what's going on up here. Alright, so in order to solve this, I'm going to go right back to what we've been doing. No different math rules. All I'm going to do is multiply straight across the top. So 3,000 times 1,000 times 1 times 2 times 60. Okay, divided by 1, divided by 18, divided by 8, and then I don't know why we're going to do it, but divided by 1 again. And that gives me a grand total of 2.5 times 10 to the 6th grams of H2O. We needed to figure out how much isopropyl we had. C3H7OH. That's how many grams of isopropyl alcohol I'd have to produce, or to come up with, in order to make my pure, delicious water. Now, don't go trying this at home. I would highly recommend not trying to make water out of your isopropyl alcohol. It's a terrible idea. That would be probably the worst business ever. But you could do it. And I could figure out anything. If I wanted to figure out how many liters of carbon dioxide, I could do that too, because this is a gas. I could do the same step, get to right here, but then instead of my ratio being 8 to 2, my ratio is now 8 to 6. I can plug that in there. Then I'm going to get to moles. I know what a mole is. Now I can plug in, 22.4 liters. There's lots of things we can do with this. We're going to be doing lots of problems. I promise you, you'll feel comfortable with them. If you don't, come in and get that extra help. I'll be glad to work with you on this. Alright, have a great Thanksgiving break if you have any left. And if you're watching this Monday morning, we'll be getting after it here in a few hours. We'll see you later.